So you can title this section, Somehow Even More Equation Review. So we're going to be starting from chapter 6, back when we wrote out expressions. So these ones we're writing out equations because it's asking us a question. Now, it says this. Sandy bought a soft drink for $4 and 6 candy bars. She spent a total of $16. How much did each candy bar cost? Anita, what you get is your equation. 4 plus x equals 16. What do we think about this? We've got something that we're missing in this equation. What are we missing, Daniel?
4 plus 6x?
Yes, 4 plus 6x. So, we got it almost completely right, says Anita. She spent, so she bought, which means she spent $4. Excellent, there's our 4. And 6 candy bars. But do we know how much each candy bar costs? Do we know originally? No. So that's our variable. How much does each candy bar cost? And we then know she spent a total of $16. So 6 candy bars times the cost per candy bar, which we don't know. Now, when we solve this, and this is what you guys have trouble with, what is it that we have to do? We have to do something. You guys do it in your head, and you guys don't do it on the paper. So, Adriana, what's the first step we have to do here? Minus what?
4.
Yeah. So we take away that 4. So we just take that away and we're good, right?
No.
What else do I have to do, Rocco?
6 candy bars divided by 2.
So I have to do something else. What do I do, Rafi?
Oh, that's 6 times 2.
Not yet. I'm still missing something. Not 6 times 2. What do I have to do, Gloria?
16 minus 1.
16 minus 4. I have to do the same to both sides, everybody. I have to do the same to both sides. This is showing work. So we get rid of that 4. We are left with 6x equals 16 minus 4 is 12. Now what can our next step be, Rafi? So we are kind of there. You're saying the right things, but I want to hear it. Malia.
12 divided by 6.
Yes, so 12 divided by 6. Is that it? What do I do, Ben? Well, I have to do both sides divided by 6. 6 divided by 6 is 1. That goes away, and I just get x equals 12 divided by 6 is 2. So I find out that each candy bar costs $2. You must show your work. You must know how to do that. So, this is a little trickier. The sum of 3 consecutive numbers is 81. What is the smallest of those 3 numbers? So first we're going to break this down because I know you're not used to some of this. Consecutive. What does consecutive mean? What do we think it means, Rocco? Single? That's a good guess, Ben. Repeatedly? We're closer with repeatedly. Tobias? In what? Consistent. We hear consistent. We hear repeated. So what do we think, Gore? It's kind of like least to greatest. It is in a very similar way. Yes, Daniel? It's not multiplication. So consecutive means, right, Rafi? It is kind of repeated addition, yes, because it means numbers in a row. So, for example, consecutive would be 3. It's not letting me write. It'd be 3, 4, and 5, because those numbers come in a row. Consecutive means in a row. So that's why when we heard those that's when we heard those going in order, least to greatest, we heard all of that, we were getting it. So do I know what the smallest of those numbers are? Do I know? What is it, Ben? I don't know. So I get x is my smallest number. So then what would my next number be? If x was my smallest number, and let's say 3 was my smallest number, then I had 4, then I had 5. What would my next smallest be, Anita? 2. It's not going to be 2 because we don't know what x is. What if x was 100? So what would it be? If 3 was x, how do I get to 4? What do I do, Ben?
X squared.
Not x squared. That would be 3 squared is 9. How do I get to 4, Michelle? Yes, so it would be x plus 1. Because 3 plus 1 is 4. So how would then I get to my 5? How would I get to my 5 then? Let's see. Miles. Yeah, it'd be x plus 2. So now I've got my 3 consecutive numbers. And it's asking me for the sum. What is sum then, Carmen?
So it would be x 1x plus 2x.
So sum means addition. Yes, so we're going to be adding these terms. We've got term number 1. We've got term number 2. We've got term number 3. Those are our 3 consecutive terms. And what is it equal to? What is it equal to, Lucy? 81. Now I need to do something here. What do I need to do to make this look a lot less messy? What do I do, Elsie? Parentheses is a great guess. We could be putting things in parentheses. But what could I do, Daniel?
Fill in x.
Fill in x. I don't know what x is yet. I got to do something first. Lucy? Combine like terms. Combine my like terms. So now when I'm looking at this, I'm looking for terms with the same variable or terms without a variable. X. Let's see. I want to make it darker. I've got x. I've got another x. I've got another x. Do I have any more x's?
Yeah. The one over. Oh wait, no, never mind.
So how many x's do I have, Oswaldo? So I've got 3x. Then let's see my other like terms. What are the other like terms that I have then? What are the other terms that are similar? Jaden? So our other terms that are the same are 1 and 2. When I combine 1 and 2, what do I get, Liam? So then we solve this and we get 3. And it's still equal to 81. So now we've added x plus x plus x gets us 3x. We've added 1 plus 2, that's gotten us 3, and we have our equal to 81. Now we have to show our work. Ben, how do we show our work?
At this point, I don't even know what that.
How do we show our work, Miles?
You put a minus 3 under the 3x and under the 81.
Like that?
Yeah.
Super duper close. I don't put it under the 3x. What do I put it under, Malia?
Plus 3.
The plus 3, exactly. So I have to cancel out that plus 3 with the minus 3. That's now gone. And what's 81 minus 3 then, Rafi?
78.
Perfect. So then I'm getting 3x is equal to 78. Now what do I have to do, Ben?
You have to find 78 divided by 3.
Perfect. So I divide each side by 3. That goes away. I am left with x equals, and what is 78 divided into 3 parts, Lucy? 26. Excellent. So the smallest of those 3 numbers is 26. What are the other 2 numbers?
I know.
What are the other 2 numbers, Daniel?
27 and 28.
Perfect. We get if x equals 26, then the next one, x plus 1 makes it 27, and x plus 2 makes it 28. And if we added all of those numbers together, if I added them together, I would get 81. Benny sold half of his comic books and then bought 7 more. He now has 11. How many did he begin with? I want you to write this problem down, and I want you to write out the equation. First things first, I have to identify my variable. Ben, what's our variable? Yes, but what does X stand for? Excellent. How many books did he begin with? That's our X. We don't know. So then, Benny sold half of his comic books, then bought 7 more. What's the equation? Who can tell me the equation? Let's see, Lucy. Perfect. 1/2 x plus 7 equals 11. Did anybody have a different way that they wrote the same thing, Romario?
11 minus 7.
That's good, but remember, we can't have a variable exclusively on the other side. That's the next step, actually, so I'm going to call on you for that. Michelle, how'd you write this? Excellent. Who's right? They are both right. They mean the same exact thing. And to show it to you, 1/2 times x over 1, because anything over 1, we get x over 2. Same exact thing. So, Romario, you were saying, what's your first step that you did? Exactly, you subtracted 7 from 11. You subtracted 7 on both sides is what we need to do. Once again, these two problems are the exact same. I'm just showing you that they are. That goes away. We get 0. So now we've isolated the variable halfway. And then 11 minus 7, we get 4. So now we have 1/2 x equals 4, or x over 2 equals 4. So now what is my next step? What's my next step then, Tobias? I gotta isolate it. So what do you think we do, Rafi? Perfect. So he says, divide by 1/2 on each side. Yes. So what is dividing by 1/2 by? What is that the same as, Ben? No. Dividing by 1/2 is not the same as dividing by 2. Otherwise, they'd be called the same thing. Daniel? Dividing by 0.5, that is the same. Yes. Elsie? Multiplying by 2. So if we did Kentucky Chicken Fried, x divided by 1/2, we would get keep, change, flip. And if we look, x divided by 2 times 2 on each side. That goes away. 4 divided by 1/2, same as 4 times 2. We get x equals 8. We get x equals 8. I'm going to make it darker so that we can see it. X equals 8. This next one. Oceanside Bike Rental Shop charges $16 plus $9 an hour for renting a bike. Tim paid $70 to rent a bike. How many hours did he pay to have the bike checked out? So he paid $70. We know it's equal to 70. It charges $16 plus $9. And do I know how many hours?
I know.
Do I know how many hours? No. So it's 9H. Now, before I continue, I've got some questions for you guys. We've got some terms that we've seen before. We've seen the terms coefficient and constant. We've seen the terms coefficient and constant. What is our coefficient in this term, or in this equation? What is our coefficient? What do you think it is, Rocco? He thinks it's 16. What do you think? Does anybody else, does people agree? Daniel, what do you think? He thinks it's the 16. Let's talk about that, the coefficient. So based on that, what would you think our constant is? What would you think it is, Gore? He thinks it's 9. So basically what we've decided here is that our coefficient is 16 and our constant is 9. Now let's think. Do I constantly pay $9, or does that amount change based on my hours? No, it changes based on my hours.
Yeah, it doesn't say anything over there.
Because I have to pay $9 for 1 hour, $0 for 0 hours. I'd have to pay $90 for 10 hours.
See, if I say for regular 2 hours,
So what about that 16? Does that 16 ever change?
no, you only
That 16 never changes. I only pay that $16 once. So the constant is 16 because I only pay it once regardless of the equation, and my coefficient, the is the co-pilot to my variable. It goes with my variable. Is the 9H my coefficient? No. It's just the 9. The H is my variable, the 9 is my coefficient, and the 16 here is my constant. So then what I do is I have to do the same thing that I do for all of my steps. Right here, I'm going to subtract 16 on each side. That goes away. I am left with 9h is equal to 54. On this, I want to isolate my h, says Ben. I divide each side by 9. I get h is equal to 6. So it's just isolating variables. Last of the writing equation work problems. Tim spent half of his allowance going to the movies. He washed the family car and earned $9. What is his weekly allowance if he ended up with $18? I want somebody to give me the entire equation. Lily, what's the variable? What don't we know? We don't know his weekly allowance, so that's going to be our x. Tim spent half of his allowance. Half of his allowance. We actually remember, of means times. Half. So we've got 1/2 times his allowance going to the movies. He washed the family car and earned $9. What operation is earning something, Daniel? Plus $9. And then he ended with 18. So then we just have to solve. Matthew, what's the first step when we solve? Malia, what's our first step?
Isolate the variable.
We isolate the variable. So how do we do that? What's the first step in isolating the variable, Anita? We could make it x over 2. That's the same thing as times 1/2. That's the same thing. That's great. Rocco.
We gotta do this, subtract 9 on both sides.
Yes, we subtract 9 on both sides.
Can I go to the bathroom now?
So we get 1/2 x and or what Anita said, which makes it easier, which is x over 2 is equal to 9. This is pretty easy. Now what do I do, Matthew? Elsie, what do we do?
We divide each side.
Yes, so what would we divide by on each side? So we're not going to divide by 2. We would divide by what, Rafi? 1/2, which is the same as multiplying by 2. So we get, for our answer, x equals 18. Who can refresh my memory about slope-intercept form? Slope-intercept form, Daniel? So it's going to be y equals? Perfect. mx plus b. Now, importantly, which one is our slope? Which one's our slope, Gore? B is not our slope. What is it, Elsie? M. Yes, I saw you the first time shaking your head. And then, so based on that, what is our slope then, Rafi? B. Or is that's not our slope. That's our y-intercept, if I said that. So I said that. That was my bad. So in this case, what we have is our slope is M, and our y-intercept is B. So based on that information, everybody should be able to answer these questions. Based on that information, every single person should be able to answer these questions. Okay. Romario, what is the slope of the first one? So it's negative 1/3. Do we include the x?
No.
No, that's just a variable. So then, Emerson, what is the intercept for that one? What's the y-intercept? Perfect, it's 1. Excellent. Matthew, what about the next one? What's the slope for number 2? Negative 2/5. Thank you, Jasmine. And then what is the y-intercept then, Lily? Negative 2. Excellent. Matthew, without any assistance, number 3, what is the slope? 3/2. Perfect. Thank you, Matthew. And then Anita, what is the y-intercept? No, the y-intercept for number 3. 3. Excellent. Fernando, what is the slope for number 4? Negative 8/3. And then what is our y-intercept, Ben?
Our y-intercept is plus
4. Excellent. So that is not that hard to identify these. The last thing I want to look at is this problem with our graph. So What would our equation be? We're already given our slope and our intercept. What is our equation, Elsie?
Y equals negative 1x plus 2.
Excellent. Y equals negative 1x plus 2. Is there another way that I could write that?
No. Oh my gosh.
What do we think?
No.
There is one more way, but it's just a little different. Negative 1x is the exact same as negative x. Same exact thing. So she's perfect with that. That's our equation. Now we have to graph it. When we graph it, we come up with our t-chart. Let's come up with it when our x is negative 1, when our x is 0, and when our x is 1. All we have to do is we plug in for our x value. I plug in negative 1 for x. What's negative times negative 1? Negative times negative 1, Oswaldo. 1. So I'd get 1 plus 2. 1 plus 2 miles, what do I get?
3.
3. Now let's plug in 0. Instead of negative 1, let's plug in 0. What do I get when I plug in 0 then, Michelle? What do I get, Oswaldo?
0.
I would get 0, and 0 plus 2, Michelle? 2. Excellent. Now I plug in 1. What's 1 times the negative, Gloria? It's negative 1. And then what's negative 1 plus 2, Liam? We get 1. So we'd graph that. At 1, we'd get 1. At 0, we'd get 2. At negative 1, we'd get 3. And look at that. Our y-intercept when x is 0 is 2. And we are going down 1 between each of our slopes. If you were given a problem where you were given the slope, if you're given a line, if I were given this problem, I'd find when x is 0, what do I get y to be? In this case, when x is 0, if x is 0, y isn't yet on this graph. I'd have to bring it down. But I know here that when x is negative 2, y is 0. And I just fill out my chart. Here, when x is negative 3, y is going to be 5. So what is my slope going down by? It's rise over run, so I'm going down 5 over 1. So my slope is y equals negative 5x. Then I have when x is negative 2, I get 0. So negative 5 times negative 2, we get 10. So I have to take away 10 to get it equal to 0. I have to take away 10 to get it equal to 0. We will continue practicing this tomorrow.